Your agent just hung for 90 seconds while waiting on 3 API calls that should have run in parallel. If you've ever watched a LangChain or CrewAI workflow crawl through tasks one at a time, you already know the pain. And you're probably wondering which framework actually handles concurrency without falling apart. Let's settle it. Here's the core problem. Both LangChain and CrewAI are built on top of Python's async ecosystem, but they expose it very differently. When you write an agent that needs to fetch data, call a tool, and query an LLM, the naive implementation blocks on each step sequentially. The framework isn't broken. You just haven't told it these operations are independent. The difference between a 2-second response and a 20-second freeze usually comes down to whether your await calls are actually running concurrently or just pretending to. LangChain gives you the most direct control. Every core runnable exposes both an invoke and an ainvoke method, and the real power shows up with abatch and RunnableParallel. If you have 5 documents to summarize, wrapping them in abatch fires all 5 LLM calls at once and gathers the results. The catch is that a single blocking call anywhere in your chain, a synchronous tool, a request library instead of HTTPX, a CPU-heavy parser, poisons the entire event loop and everything grinds back to serial execution. People blame LangChain when the real culprit is one sync function buried 3 layers deep. CrewAI takes a different philosophy. It's opinionated about orchestration. So instead of you manually wiring async calls, you declare tasks and let the crew decide execution order. As of the newer releases, you can mark tasks with async_execution equals true, and CrewAI runs those in parallel while respecting dependencies between agents. This is fantastic when your mental model is these 3 researchers work independently. Then the writer combines their output. You get concurrency almost for free, but you give up fine-grained control over exactly when and how each await happens. So which one freezes? In practice, LangChain freezes when developers mix sync and async carelessly because it trusts you to know what you're doing. CrewAI freezes less often at the task level, but it can stall in a more frustrating way because the orchestration layer sometimes serializes steps you assumed were parallel, and you have far less visibility into why. Debugging a LangChain freeze means auditing your own code. Debugging a CrewAI freeze means fighting the framework's assumptions. Let me give you a concrete rule. If your workload is a fan-out pattern, many independent calls you want to blast simultaneously, LangChain with abatch and asyncio.gather will beat CrewAI on raw throughput almost every time. But if your workload is a structured pipeline where agents hand off to each other with clear dependencies, CrewAI's async_execution saves you a mountain of boilerplate and keeps the logic readable. Match the tool to the shape of your concurrency, not to the hype. And here's the trap almost everyone falls into. They benchmark with a single request, see it work, and ship it. Then production hits with 50 concurrent users. The event loop saturates, and both frameworks appear to freeze because you never configured connection limits, semaphores, or rate limit backoff. Concurrency isn't just about the framework, it's about the whole stack around it, from your HTTP client pool to your LLM provider's rate ceiling. So test both under realistic load, profile where the actual blocking happens, and pick based on your workflow's shape rather than a benchmark screenshot. Tomorrow I'm publishing the hands-on follow-up where I build the exact same multi-agent pipeline in both frameworks and stress test them side by side with real latency numbers. So subscribe right now so that comparison lands in your feed the moment it drops.